let's go ahead and do this example that should be in your notes. If you don't have one, you can ask the sub for one. So let's look at this example of how to graph. So y equals ax squared plus bx plus c. This is written in standard form. So in order to graph, we need to graph this in our calculator, but let's first identify a. A is -2, b is +8, and c is -8. So we need to answer a few questions about this. I am going to go ahead and graph it in my calculator to begin with. So whatever's in there, I'm going to clear out. Go to y equals, let's put this in, -2x squared plus 8x minus 8. Make sure you put -8 and not -8. Negative is only when there's not a term in front of it. Hit graph. So let's see, does it open up or down? Up would be opening upward, downward would be going down. So this is opening down. Is this vertex a max or a min? It is the highest point, so that would be called a max. The opposite would be a min. The y-intercept, you know what's really cool about these graphs? Whenever you hit the word trace, look at where my finger is. I hit the word trace, it automatically goes to my y-intercept. 0, -8, which is the c. The c value is our y-intercept when it's written in standard form. Then we need the axis of symmetry. Great thing is we can look at our graph and find it. So axis of symmetry is a line that cuts it down the middle. So I'm going to use a piece of paper and I'm going to find out what is going to cut it down the middle. Right there. So it's always written as x equals, so that's already written for us. X equals 1, 2. X equals 2. It's that dotted line that goes right down the middle. So when we graph this, we're going to go ahead and start with that dotted line. And then we can find a few points. So I'm going to start with my vertex. The vertex, it's right there. It's at 0, 2. This is my vertex. So I'm going to make my x and y table with 0. No, it'd be 2, 0. And then I'm going to go to the table second, graph for the table. I'm going to find that vertex, 2, 0, and then I'm going to do a couple of points, 2 points after it. So 3, -2, 4, -8. Then I'm going to go back, and I'm going to do the one right before 2, which is our vertex, 1, -2, and 0, -8. So now I have 5 points that I can graph and draw my quadratic parabola. So hit graph. As I'm plotting these, I want to make sure to look at my graph here. So 2, 0 is my vertex. I'm going to go ahead and write that here. So I'm going to go over here. 2, 0 is already there. The next one's 3, -2. So it's right here. Then we have 4, -8. 4, -8. And then let's go back 1. So 1, -2. These are reflected. They're reflections of each other. See how they're the same number of units away from our axis of symmetry? And then the other one is 0, -8, which is also our y-intercept. Go ahead and make your parabola. I always start out with those first 3 points. And then extend. Okay, and then I just take one more glance at it, make sure they look the same, and they do. So we would be done with that graph. So this should be in your journal. It should be glued in the next page. Let's go ahead and look at y'all's assignment for today. So you're going to answer the questions. You can use your notes for this. So answer the questions, and then 7 and 8 and 9 are just like the example that I just finished doing. And then 9 through 12 is domain and range. So I want y'all to look back at our notes for domain and range. So quadratic functions, domain and range, we're going to write as inequalities. Domain is your left to right, just like a x-axis. And then range is down and up, just like the y-axis. If the quadratic function has arrows, so let's look at this example right here. You may have already done this. If you did, just watch me. When we do domain, we look left to right. The arrows are telling us it's going to negative infinity and positive infinity. So when we have arrows going left and right, that is x is all real numbers. That's an R with an extra line on it. And then our range, I'm going to do in green, is how far down to how far up. So it goes down to, let's see, what is that? 1, 2, -2. And up to infinity. So whenever it has arrows, we are going to use the variable y and the number. Then we are going to look at, it's at -2 and it goes up to infinity. So that means it's going to be greater than or equal to -2. So the last question is this a max or a min according to our vertex? And here's our vertex. It's the lowest point, so it's a minimum. Okay, let's look at the you try it number 3. If you've already done it, just watch. If you haven't, you need to complete it with me. This has endpoints, so it's going to be a little different. So we are going to use the template. Oh, y'all can't see that. And this would be X or Y. For domain, we're looking at X, so we look at how far left and how far right. So left, so it's at 2 here, it goes to 1, it stops at 0. It doesn't go past to -1. See how it stops right there? A lot of people want to say 9, but 9 is on the y-axis. On the x-axis, it doesn't go past 0, so it goes left to 0. And then right, it goes, let's count from the origin, 1, 2, 3, 4, 5, 6. I think that's a 7. Yeah, that'd be 7. So it goes 0 to 7. So we write that with X sandwiched in the middle. These are both closed dots, so we're going to use the less than or equal to on both sides. And put the numbers, 0 and 7. So you put the smallest number to the largest. Okay, and then we have range. Range is our y-axis, so we see how low does it go. How far down? So that's -1, -2. How far up? 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes up to 9. So we're going to write it as an inequality with y because it's range. This touches, so it's less than or equal to. And then we put the -2 and +9. And then we want to talk about max or min. This is a minimum because it's our lowest point. Okay, let's do one last one. You try 4. Let's do our domain first. Domain is x. We're going left to right. So we want to see how far left does it go? How far right does it go? Left is -1, 2, 3, 4, 5. It looks like -5. And how far right? Looks like that would be at +1. This is an open circle. So whenever we write it, we're going to do just a less than to the x, then less than or equal to 1. And then we have range. Range is how far down. These are uneven, but we want to see what is the furthest down, and it is right there. Even though they're uneven, I'm not going to draw it a diagonal. I'm going to draw it as low as it goes. So that looks like it's at -1, 2, 3, 4, 5, 6, 7. -7. And how far up? To 1. So we put y, and this is a closed dot. Even though this is an open dot, we are using the lowest, which is closed. And then it goes up to 1. And then we look at our vertex, which is that point right there. That is the highest point, so this is a maximum. Okay, so you're going to finish the worksheet, front and back, all 12 questions, turn it in, and then work on the Delta Math extra credit.